Welcome back. This is episode 81 of the Rule Your Pool podcast, part 2 of our concrete special with Bill Drakely from Watershapes University and Drakely Pool Industries. Jared is with me as well. Let's be honest, we're recording these back to back. We're still in this same conversation, but we've broken it up over 2 weeks, to extend out. There's only 52 weeks in a year. It's hard to come up with.
We don't want to drag
episodes.
Bill through this week to week. We just got to get Bill, in the game.
He's got stuff to do. Well, Bill Drakely, thank you so much for being back with us.
Welcome.
All right, so in this episode, we're now going to talk about plaster finishes. They are also cement-based. Last episode, of course, we talked about concrete, specifically shotcrete pool shells. Now we're going to talk about the fine finish that goes on top of them. Before we go into this, as we mentioned at the end of the last one and many episodes before, we are teaching with Watershapes University, Bill included, in the Las Vegas International Show in 2022. That's November 12th and 13th. There are only 60 seats available. You can sign up online for that. The class number is WUC3611, the Essential Plaster Workshop. It's a real honor to teach with Watershapes, and it's a real honor to have Bill on here because he is a true subject matter expert on concrete. We at Orenda are not. We deal with the chemistry issues that water will do to these cement finishes, but we want to really understand what are more of the structural issues. What are the issues that are not chemistry related? That's what we're going to talk about in today's episode. So unless you have anything to add, Jared or Bill, let's get right into it.
No, I'm looking forward to getting the plaster side of this conversation done because that is what we mainly deal with, for sure.
All right, let's go. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. Okay, Bill, in the last episode we talked about cracks, and you said we could talk about these for hours. Well, we see very, very small cracks, and I'm imagining they're shrinkage cracks too, but they'll just spiderweb all over a pool. And these, as we're told, happen primarily on hot days or windy days. Help us understand what's going on there.
Well, if everything else is correct and you have these cracking scenarios on a hot day or windy day, you're losing your moisture on the surface of the concrete. So the wind will take it or the sun will evaporate it out. And what happens is when the concrete chemistry and the moisture changes, that material is going to shrink. And when concrete shrinks, it has to crack. So when it goes from its plastic state to a hardened state, there's got to be a relief somewhere, and that relief shows up in a crack, and that's what happens. But you're losing moisture prematurely before it's hardened.
Can that be undone when the pool is full?
Can it be undone? Can you get rid of the crack?
Yeah, can they fill in?
They act differently when water's in the pool, absolutely. You're in a constantly hydrated state. I'm sure that cracking would probably seal up or get smaller. But the concrete crack in and of itself, once it's there forever.
Mm-hmm. Something could fill in it, but the crack has already been made. You can't.
Yeah, how do you minimize that? Because obviously, where I'm in Texas. It's summer. It's 105 outside and sun beating down on a surface, and there's no relief here whatsoever. And we can't just sit there all day spraying water on a plaster surface after it's applied for a number of reasons. Number one, time. Two, you're hydrating and curing this surface at a different rate than everywhere else. So how do you manage that?
Well, a concrete crack happens when it's hardened. Your plaster shrinkage crack is happening before it's getting hard, correct? So you put the plaster on the pool and you start filling it in Texas. That plaster compressive value, that plaster durability, that plaster performance it's too fresh and too new to be hardened where it's not going to harden anymore. So I would think you have a degree of, I don't want to call it flexibility, but a degree of movement still within the plaster matrix that you don't have in the concrete, correct?
I would assume.
So, if you're going to all of a sudden, it's full of water and underwater, with this shrinkage, this loss of moisture, reverse itself and go back. I don't know the answer to that, but I would imagine it would happen more probability in plaster than would in the concrete.
Why would it be any different? Because it's still cement chemistry.
Yeah, but the cement is not as hard in the plaster as it is in the concrete.
Just because it's so new.
Yeah, because it's brand new.
Since we're talking about hardness of, I'm assuming you mean compressive values, PSI, Do you use the same water to cement mix ratios for plaster that you do with shotcrete?
I doubt it. I don't know that because it's hard to measure in plaster. You're troweling it. Your application finish, putting the plaster on the pool, you're squeezing the moisture out of that plaster. I don't know what the water cement ratio is after you trowel and squeeze and finish it. I do know what it is in the pool.
What is it on the truck?
0.38 to 0.48, no more than 0.50.
Okay, so the same exact parameters as you would have for shotcrete, right?
Right, proven through a core analysis that we do testing in a lab too. We do a petrographic analysis, Eric, and then we test Portland content, aggregate content, water cement ratio, pozzolans, all that stuff. Chewing the back of the guy spitting the sample. We can test all that.
So what are some of the issues that you have seen in your career here that result from improper water to cement ratios?
For plaster.
Plaster, yeah, or problems with the shotcrete coming through the plaster, since you said the plaster mirrors what is underneath it.
I would say 95% of the plaster problems start with concrete in the pool shell. And I said this on the last podcast we had, and I say this in all the presentations I do, for whether it's for the National Plaster Council, to any WaterShape, to anybody. Pool concrete is the biggest problem when it comes to plaster success or failure. You get a hollow, or you get a debond, or you have penetration through the plaster and staining the plaster of moisture coming through the shell. I mean, this is not the plaster guy's fault. Again, I'll say plaster guys are such nice people. You lead with your chin and you get punched before the pool shotcrete guy does, and he's the one who deserves it because he's the one who put in the lousy shell that's making the plaster fail.
What are some of those issues? Because you said it comes through. I can think of two examples, but the one that stands out is I have seen like vertical rust stains that are like 2 feet long, just perfect rust lines. And that has to be rebar, right?
Well, it's rebar, and it's a lack of coverage. WaterShape University recommends 3 inches based on ACI guidelines on steel in a moisture condition. Well, 3 inches from the soil, and if you have water in a pool, 3 inches in front. So your minimum thickness of a concrete pool wall, if you got 3 inches of coverage over your steel, is 7 inches. The steel cross section and the 3 inches of concrete. Now, I don't know anybody in this pool industry that can do a straight wall and not have a variation or a waiver. So let's call it 8 inches because wire ties and whatever. Right. So the minimum thickness of a pool structural wall should be 8 inches. So when you, Eric, get a vertical grid that shows through, there's not enough concrete covering the steel. The water penetrates the plaster, it penetrates the concrete, oxidizes the steel expands, it bursts, and it gives you a structural crack. Let's define a structural crack. A structural crack is a crack that changes the design intent or the design performance of that swimming pool. So water oxidizing a piece of rebar is a structural crack. I can have a shrinkage crack in a certain area and have water go through it. If it doesn't touch any of the steel, my compressive value is still strong, and the pool doesn't leak, well, who cares? You got a hairline crack, so what? Doesn't change the performance of the pool or the designed intent or the engineered intent. But when you get a crack that changes that, you got a problem because all of a sudden the performance is going to change, and that's not what it's supposed to do.
I like that definition.
I do too, and I think that just kind of draws me back to what you said before of the plaster surface mimics the shotcrete or the gunite underneath it. So if the rebar is too close and it's going to oxidize that, your plaster is just going to mimic what's underneath it and pull it through, right?
Yeah, absolutely.
Well, you mentioned something that kind of got my brain. I was at a spa or a pool spa combo. I don't remember where I was. They had nodules everywhere. I mean, thousands of them. Little nodules.
Calcium nodules.
Yeah, calcium nodules. They almost look like little blisters of calcium coming through.
White volcanoes just all over the place.
Right, white volcanoes on a colored plaster, tiny little things, but just thousands of them. I've also seen them get really big, like the thickness of my finger, and droop down. They're pretty ugly. But my understanding is that is efflorescence because of back pressure from moisture coming through behind the plaster, whether it's coming through the entire shotcrete shell and then pooling up behind the plaster or whatever it is, it's coming through the plaster, bringing minerals out. How does that even happen?
I've seen these little calcium or these little, you're talking about on the surface of the plaster, a calcium nodule?
Yes.
Okay, I'm not so sure it comes through the concrete. I have not seen any testing for that, but let's say it does. How is it getting there? There's got to be a pressure pushing that moisture through the concrete shell, and the shell's got to have a permeability factor that allows water to go in or out at its convenience.
In this case, it was pretty clearly groundwater. It was a coastal area.
Yeah.
So you assume the groundwater was high because it wasn't actually everywhere. It wasn't like in the top foot of everything.
It's basically at the water table.
Yeah, it was right at what I would assume to be the water table.
It was all the way around at that level?
At that level, everywhere. Walls, benches. It was not on the sun shelf because that was a little bit shallower. But everywhere below that, it was all over the place, pretty uniformly. And it was not a waterproofed pool. And we do talk to builders about waterproofing, especially in coastal areas, because it actually prevents nodules from coming back. So far, we're on several years of no nodules coming back for certain builders in coastal areas. And it's, there has to be a permeability factor. I agree with that. But from everything we've learned about nodules, everyone agrees that it's coming from within the plaster, whether it's being pushed from behind or a weakness is created from water chemistry coming into that plaster to create it out and drawing it out. There's disagreement there, but the point is it's not scale. It's not from the pool chemistry and landing on that surface and creating a volcano. It's coming through. Whether it's being pulled through or pushed through, that's up for debate. But from everything that we've ever seen, it has always been a waterproofing failure or a water tightness failure. Every single time.
Or I've likened it to the calcium being added to the plaster mix to heat it up, and do those pockets of high concentration of calcium come into play here? How does that play into this equation?
Well, I don't know if it does. I mean, if you're talking about these nodules that are site-specific on the inside of the pool, based off of groundwater, based off of temperature, or based off of winterization procedures or whatever, you have a moisture issue within the concrete that is moving or being drawn. I've never seen a sample of shot material that has these on them, that have these grown from them or moisture through them.
You want some?
Yeah.
I'm sure there's enough listeners on here who have nodules who could get a core sample.
No, take some pictures and send them. Absolutely.
Oh, dude, I've got so many pictures of this. Yeah.
But if your sample of, okay, I have the groundwater is at a certain level and these nodules are at that level or below, then it would tell me that the water level of the ground, what's it doing to the pool shell to grow these things at that same level all the way around? Because there's a direct correlation. Is the moisture penetrating the shell in a very porous and permeable area and getting to the backside of the plaster and having this as a result of it? Okay, that may be the case. I don't know that, but I would like a core all the way through the shell and see what it does versus where it doesn't do it, and then take a look.
And when you talk about coring, that's something we've thrown around an awful lot. I just visualize you getting in there with a drill and taking chunks out of this plaster surface, which I don't know if anybody would love the idea of doing that, but is that what you're referring to?
Yeah, ASTM 1604 is a shotcrete core standard testing method. So you take a 4-inch core out of that wall and you take a look at aggregate dispersion, chemistry of the concrete, voids, effervescence, all this stuff. You take a look at all of it and see how the plaster is sticking or what is the bond issue. And you can see, like we go through our concrete classes, we've cored pools that are being in lawsuits, and there's different colors of cement, different colors of sand, rebound, air pockets, non-encapsulation steel.
I'm assuming when you go down the process of coring out a pool, you've pretty much already determined that you're replacing or fixing after you do that with either replastering, gunite or something. You're just not going to core a pool that's in my backyard
and leave a hole in it.
Yeah, fixing it.
Well, the service company or the pool company will fill the hole. Most of the time we do coring,
just patch it.
Well, most of the time we do coring, there's a serious problem. I mean, I'm not coring through a shrinkage crack or a pot of rebound. I'll just hammer through that and whatever it is. We're coring on a pool that's settled differentially. We're coring a pool that has structural issues, or the steel is in the wrong place, or there is a continuity issue with an extra millivolt running around through the water. We're doing some serious testing.
So hear that, everybody listening? You're not going to just core a pool to core a pool. You have a serious problem if that's what you're going down. Just FYI.
Yeah, it's probably a chip out and replaster. I agree with that. I mean, it can be patched, but some of these nice pebble finishes, they're very hard to patch. That's not going to look the same. And
yeah.
But in the interest of time, we could keep talking about nodules. We see it very often. We do get a lot of calls about it because people ask if SC1000 can clean it up. The answer is like maybe temporarily. We've always kind of viewed it as like a blister that just needs to run its course, because some of them will just stop after time because they were we believe, plastered over like a puddle in the bottom of the pool. And it's only in this one area that you have 5 or 6 nodules, but nowhere else in the pool. And that happens to be the lowest spot in that pool. That's where the nodules are because they plastered on top of moisture. At least that's what the NPC said, or that's how we interpreted it. Mm-hmm. I don't want to be in that game. That's another reason you're on here, Bill, is because we know that it's not specifically caused entirely by water chemistry. Some people think that water chemistry can initially cause the damage, like that pinhole weakness in the plaster. I personally don't buy that. I've never seen that happen because water chemistry is sort of nebulous when it etches. It just etches at the most convenient place, path of least resistance. It's not going to drill down on this one thing unless the weakness was already there. So the idea that this is a reflection of the concrete underneath the plaster, that really resonates with me because that bench that I tapped on sounded noticeably different than everywhere else in the pool. It was hollow.
It was a lack of bond of the material to the concrete surface. So if this moisture and this calcium movement is now between the concrete and the plaster, you have a debond area or an expansion where all of a sudden you get a hollow point. We see this all the time. I mean, you have poor concrete quality, okay? And you don't have an initial bond that's going to last the test of time. You don't have a three-dimensional bond plane that's not 4,000 PSI. It's dirty, it's sandy. I mean, dry gun shells, if they're not cured and they're not at the right water cement ratio and the right Portland content, leave a sandy surface, a tan sandy surface. If there's not enough Portland in the mix, what color is the concrete? Well, what the hell? It looks like the beach. It's sand. And you plaster over sand, you're not going to bond to a loose, gritty surface. The only way plaster bonds is to a nice, tight, hard surface. So if a plaster company gets there and they wet down the shell and it looks like it's 2,500 PSI, then you got bleeders coming through and it was dry as a bone, and you wet it down as a plaster company and water wicks right through the plaster. Well, guess what? That plaster is going to, once it's on and once it goes through some time, it's going to have a debond because it never had a chance to set, no penetration into a quality material to make that locking mechanism.
Just time out here for the recording. Are you bumping into your microphone when you're talking?
No, I'm pounding my desk.
Oh. Yeah, there you go. Yeah, that's definitely it. No, we'll leave this in. We don't need to edit this out.
Well, listen, you want me to talk about concrete, I'm going to start throwing my hands.
Yeah, he's adamant about this concrete.
Yeah, I know. Pound on the desk. I love it. No, you know your stuff, man. You've been doing this, and I'm sure that you learned a lot of these lessons the hard way. Is that a fair statement?
I did. I made some of the mistakes myself, and then I knew better, and then people were promoting low-quality material in some of the educational opportunities early on in the 2000s, and it's just like, are you out of your mind? This is not how you do it.
Yeah. Jared, do you have any more questions for Bill?
I don't have any more questions. It's been definitely an enlightening 2 episodes for me because this is obviously a segment of the industry that I know very little about. But I mean, we're eager to learn more about it, and we try to, but this has been awesome.
I appreciate it. I just want to mention you talked about hollowness in plaster and bondability. So we get into renovations. We see this in the Northeast where we empty a pool, whether it's a commercial pool or residential pool. And if we know the concrete's got an issue, if we leave that pool empty and the plaster, which was not debonded when we emptied it, all of a sudden has hollow spots going all the way around. And we take a look at the tile line and there's miniature cracks in the tile line and stuff like that. There's a good chance that that pool concrete never really had a good bond with some of this material, because when we take moisture away and we let atmospheric air on top of the product, everything shrinks. And without a good bond, it shrinks and pulls away. So your hollows are very, very prevalent when the pool's empty, which is why we don't like to leave pools empty in a plaster condition for too long, because of this phenomenon. So, but it all goes back to quality concrete. I've seen commercial pools that the community would empty it in the winter and then refill it in the spring for the community pool, and it had a plaster surface, and it lasted 20 years. This is the old Canadian marble put on dry gun that was 6,000 PSI. I mean, it was just, that's what you did. Nowadays, you can't do that. Nowadays, it's recommended against it, but it did happen. And the old school sometimes is a better school than what we're doing now. And, so the quality of concrete affects plaster bonding, hollowness, and performance over time, for sure.
Well, it's definitely got my mind thinking, because I came in here with assumptions of things that what research has said and field experience. Jared, you and I have experienced this along with many of our other employees and reps in the field of what we've seen. I never really drew the parallel of just how important the quality of the shotcrete was. I understand the bonding. Like, that makes sense because that's a gap between the plaster and the shotcrete behind it. But the idea that a shrinkage crack or the actual PSI of the shotcrete behind it, the plaster is going to mirror that. And it's going to start me thinking, maybe all of us thinking about some of the issues that we see. Maybe they are driven by the shotcrete behind it.
It's part of the structure. The plaster mirror is part of the structure. So 90% of your problems start with the foundation. I would start with the foundation and work out of that. And once you eliminate the causes in the pool shell, then you're very limited in the causes of the plaster guy. And I have yet to see a bad plaster crew make mistake after mistake after mistake when it comes to something like this, or cracking, or delamination, or some type of colored change in the pool, and all the chemistry's right and everything else is right, and you're like, God, why the hell did that happen? Start with the pool foundation. I mean, that's usually your culprit. As a pool guy and as a subcontractor, consultant, and the guy who watches this, most of the guys who shoot pools don't get everything right.
Well, it's hand applied. It's done with artisans, right? Skilled workers.
I don't know if I'd call them artisans.
Well, you know what I mean. Trowelers are artisans, in my opinion.
Oh, the plaster guys. Yeah, I'm talking about the Neanderthals who shoot concrete. I mean, that's the problem.
Don't speak so harshly about yourself and your kind.
Oh,
come on.
Whatever.
I doubt they listen to the Rule Your Pool podcast, but
we only have like 40 listeners, though.
No, dude, we at least broke 45. Wait, okay. We're going to break 50 on this one, I'm sure, at the rate we're growing.
All right. Okay, good.
I hope you all enjoy listening, that Bill's been able to add some value. And we are going to be teaching together with Water Shapes, not only in that class, but I think some other classes moving forward. They're doing great things. Check them out at watershape.org. And Bill, it has been an honor to have you on here. And thank you for your candor, because I don't like it when people are so polished. Tell it like it is. We appreciate that, and I think our audience does too.
I've never been accused of being polished, so I take that as an offense.
Hey, we appreciate the authenticity around here. That's right.
I appreciate you guys having me on. You guys are doing a great job, and certainly have a terrific message within the industry, one of the best. So we're happy to partner with you guys.
Right on. Well, thank you so much. This has been episode 81 of the Rule Your Pool podcast. I have no idea what we're going to talk about next, but Jared probably won't read the show notes regardless, so it doesn't matter.
Hey, if I'm just there, that's a plus, okay? So let's start there.
That's a win. Okay, everybody. Thank you for your time. Take care.
Thanks, guys.
Thanks.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.